Alright guys, so today we're going to be learning a lesson via audio and me doing it over AirPlay. So over the weekend I would like you guys to listen to this and let me know what you think. So we're on section 4.4 and we're on page 251. So let me go ahead and write that in the corner for you guys. I'm sorry about that. 251. Alright, so if you remember from last chapter, we already learned about something called standard form, and standard form goes as follows. It's ax plus by is equal to c. Now, we know that always our x and our y are going to be our variables, where our a, b, and c are coefficients. That means those are the numbers that we're actually plugging in. So if we go ahead and look over to example number 1, we have this form, 2x minus 6y is equal to 4. Alright, so in this form, this is already in our standard form, the ax plus by is equal to c, where 2 is equal to our a, negative 6 is equal to our b, and then we got our 4 equal to our c. Now, knowing that, it's asking us to go ahead and write two equations in standard form that are equivalent to this 2x minus 6y is equal to 4. So if you remember from a couple chapters ago, we talked about proportions. We discussed how 1/4 is also equivalent to 2/8, and that's also equivalent to 4/16. And what we were doing is we were just multiplying those each by 2. So they're multiplied by a factor. You multiply 1 times 2 to get 2, and 4 times 2 to get 8. And then you multiply 2 times 2 to get 4, and 8 times 2 to get 16. So when you reduce them all down, it's going to be the same thing as 1/4, which is good. So with that, we're going to go ahead and make a scale using this equation here. So we're referencing the 2x minus 6y is equal to 4. So let's go ahead and do that. Alright, so we have 2x minus 6y is equal to 4, and we're trying to make two equations that are similar to that. Well, if we go ahead and multiply this equation by 2, we're going to get 4x minus 12y is equal to 8. And if you notice, all those numbers were all multiplied by 2, so in that case, that equation will be similar to that original equation of 2x minus 6y equals 4. Now, we didn't need to multiply it by 2, we could have multiplied by any number, so let's go ahead and pick a different number. For instance, we have 2x minus 6y is equal to 4. Let's say we multiplied everything by 3. That's fine too, as long as every single thing is being multiplied by 3. So when you go ahead and do that, you get 6x minus 18y is equal to 12. And then that ends up being the same exact thing, or same ratio, same scale, as our original equation of 2x minus 6y is equal to 4. So we're all good in that sense. If you wanted to, you can go ahead and divide. That's totally an option as well. So if we go ahead and divide, that makes a lot of sense, and you're more than welcome to do that. So let's say we wanted to divide this. We had our original equation. Whoops. You had your original equation of 2x minus 6y is equal to 4. Let's say we want to divide this by 2. Alright, so if we're dividing this by 2, we're going to get x minus 3y is equal to 2. And once again, that equation is the same thing as our 2x minus 6y is equal to 4. It's just a different kind of ratio. Alright? Okay, so great. Let's go ahead and move on to example number 2. So if we're looking at example number 2, it says to write an equation in standard form of the line shown. So it gives you this line here, and if you're looking at your book, and go ahead and try and draw it on my graph, you got the coordinate 1, 1, and then you also have this coordinate down here that's 2, negative 2. Alright, and it gives you this line that's drawing through this graph, and it's asking you, alright, now write an equation in standard form of this line shown. Well, first off, you know you have two coordinates, and if you want it in standard form, you need to find out several pieces of information. So you have these two coordinates here that are 1, 1 and 2, negative 2. And from our last section and also from the previous chapters, we know that we can find out our slope using two coordinates. And we use the equation always, the y2 minus our y1 is equal to x2 minus x1. Alright, so let's go ahead and use this formula in order to find the points. Alright, so find the slope. Okay, so we have the points 1, 1 and 2, negative 2. Alright, and if we plug it into our formula, let's go ahead and label this one as 1 and this one as 2. Alright, so our y2 is negative 2 minus our y1 is 1 over x2, 2, minus our x1, 1. That's going to equal to a negative 2 minus 1 will put us at a negative 3. And then a 2 minus 1 will put us at a 1. So our slope is going to be equal just to a negative 3. So that's our slope right up in here. Alright, negative 3. Okay, so after we find out our slope, we also know our point. Alright, and if we know a point and a slope, remember from last section we're able to reference our point slope form, which is our y minus y1 is equal to our m times our x minus x1. So once you have this, you can plug in your point. So I chose the point 1, 1, so I'm going to plug that in for my y and my x. I have y minus y1, which is a 1, is equal to m, which we just found out is a negative 3, that's our slope, times x minus our x1, and that's also a 1. And we want this, that would be great if we wanted it just in point slope form, but if you look at the directions, it's saying to write that equation in standard form. And we know that our standard form is ax plus by is equal to c. And that means that we need to get both our x and our y on the same exact side, where our coefficient is left on the right hand side. So let's go ahead and do that. We're going to have our y minus y1, or y minus 1, is equal to, we're going to distribute out that negative 3 to both the x and the negative 1. So negative 3 times x is just a negative 3x, and a negative 3 times negative 1 will put us at a positive 3. So now we need to move that x to the left hand side. So in order to do that, we're going to do the opposite, which is adding 3x to both sides. And then from there you get 3x plus y minus 1 is equal to 3. Now we're almost there, we just have to deal with this negative 1 on the left hand side, which is right over here. And to move that to the other side, you just add 1 to both sides. And then from there you get 3x plus y is equal to 4. Now that actually kind of looks like our standard form. Our standard form again is ax plus by is equal to c. And we look like we're all set and good to go. So actually your answer is just the 3x plus y is equal to 4, and you could stop right there because it just asked you for an equation in standard form. If you feel like you need extra practice on this, feel free to go ahead and do number 1 and number 2 in your guided practice, and that will give you great practice at that. Let me go ahead and write down the answers for number 1 and 2 in case you're doing that. So go ahead and pause this if you're going to do it, and if not, you can go ahead and keep playing. So for 1, some sample answers are going to be 2x minus 2y is equal to 6. Another sample answer will give you at 3x minus 3y is equal to 9. So they multiplied it by 2 and by 3 there. Alright, so if you're doing that, go ahead and make note of that. Now let's go ahead and give you the answers to number 2, alright? The answers to number 2 is going to be, negative 2x plus y is equal to negative 7. Alright, that's the answer to number 2. Okay, let's go ahead and jump on over to example number 3, where we're writing an equation of a line. Alright, so example number 3 asks us to write an equation of a line, and it gives us a blue line and a red line to find the slope of. So again, we're on page 252 if you're following up here. So first it asks you in A to find the equation of the blue line. So let's go ahead and find that. So on that graph that it shows you, it gives you this kind of graph right here, and it wants you to find the equation of the blue line. So the blue line is located at 4 units down, so it's right over here, and it gives you the point of 2, negative 4. So if we're looking at this line here, notice how it's a horizontal line, which means let's pick another point here. And that point's going to put us at a negative 2, negative 4. Now if we pick a point here, that's going to give us at a 0, negative 4. And if you notice the commonality between all these three, your y is always going to be at a negative 4, meaning that your equation, since it's a horizontal line, will just be y is equal to negative 4. And that is your answer, because no matter what value you plug in for x, your y will always, always, always be negative 4. So now if we're doing the red line, which is our vertical line, you should kind of have a feeling that it's going to be an x equals something, just because our last one was a y equals something. So this one's putting us over at 4, 1, so this is our point here. So we got 4, 1, and our line's looking like this. So if we go ahead and pick another point over here, our point will be 4, negative 2. And again, if we pick a point over here, our point is going to be 4, 3. So now if we notice from this, our commonality is all in our x's. Our x's are all equal to 4. So here our equation is going to be x is equal to 4. Again, because no matter what value you plug in for your y, your x will always, always, always be 4. So let's go ahead and do example number 4 right now. Alright, if you're with me. We're on example number 4, and we're finding the missing coefficient in the equation of the line shown. So it wants you to write the completed equation. So let's go ahead and look at that line there. I'm not going to draw it, but it gives you the point negative 1, 0. Alright? So if you're looking at that graph, look at that point negative 1, 0 really quick. And then it also gives you this equation that says ax plus 3y is equal to 2. Now if we remember our standard form that ax plus by equals c, our a, our b, and our c are always our coefficients. So those are going to have values. And remember that our x and our y are variables, so you never really want to plug in any or keep any numbers in for them. Your final answer will just be x and y, where your a, b, and c have actual values plugged into it. So in this case, though, we don't know our a. So we're going to have to reference this point over here, the negative 1, 0, in order to find out our a. So let's go ahead and plug that in. You have a times your x, which in this point here it's negative 1, plus 3 times your y, which is a 0, is equal to 2. So you have a negative 1a, or just negative a, plus 0 is equal to 2. So in this case you have a is equal to, or negative a, is equal to 2. And if you divide each by a negative 1, just to get rid of that negative, you can also multiply by a negative 1, it doesn't matter. You'll get a is equal to negative 2. So if we're writing it in that equation, then we can do our ax plus by is equal to c. And if you reference that equation that they gave you in the beginning back up here, it gives us the ax plus 3y is equal to 2. We're just going to plug in our value for a. So we get negative 2x, alright, and then look back at that equation. It already gives you the 3y, so plus 3y is equal to, and it already gives you the 2. So our final answer will just be this here, and that's all you need to do for that. So basically we plugged in our point, our x and our y, and we found the value of a, and then immediately we got rid of that a, and we kept those x and y's as variables, and we just plugged it in. Okay? Alright, let's go ahead and do our last example over here, and then we will be done. Okay? Alright, we're on example number 5 at the top of page 253. So example number 5 is a word problem. It says that your class is taking a trip to the public library. You can travel in small and large vans. A small van holds 8 people. So I'm going to write that here. Small holds 8 people. And then it also says that a large van can hold up to 12 people. So we got large over here, and that holds up to 12 people. Okay? And then it says that your class could fill 15 small vans and 2 large vans. So that to me kind of sounds like a point. Alright, so it says 15 small vans and it fills 2 large vans. Alright, and it sounds like a point because it's saying that if it holds 15 small vans, then it will also hold 2 large vans. So it's kind of like that input and output value, like we did for money and total cost the other day. So if we're making our equation, A wants you to write your equation in standard form that models the possible combinations of small vans and large vans. So if you know that your small vans can hold up to 8 people, you have 8 people times the actual number of small vans that you need. So that will put you at 8 times S. Plus you're going to add your number of large people. So large vans can hold up to 12 people. And we're just going to put a 12L there, alright? So 12 people times the number of actual large vans that you need will equal the total amount of people that you actually have in your class. So that's where we're getting that equation from. Next it says that you need to plug in your point, alright? So you're graphing this equation. So in order to graph it, you're going to need to find out that value for P. And in order to find out that value for P, we're going to go ahead and use this point here that they gave us in the beginning, the 15 small vans for 2 large vans, and we're going to go ahead and plug it on in. So you get 8 times the 15 plus the 12 times the 2, and that should be equal to your total amount of people. So if you go ahead and put that in your calculator, or you go ahead and multiply that on out, you're going to end up getting 144 is equal to the total amount of people, or P, that your class has. So if you put that equation in standard form, you're just going to get your 8 times your S plus your 12 times your L, which is the large vans, is equal to 144 people that you actually have. Meaning that you can actually have a ton of different possibilities for a different number of large vans or small vans that you actually end up using. So if you look at the graph there on page 253, you notice that there's 2 other possibilities that you can use instead of just the 8 and the 15 and the 2. So go ahead and look at that, and those will tell you your other combinations of different possible van sizes that your class of 144 people is actually able to use. Alright? Okay, perfect. So I'm glad you guys got the chance to listen to this. Go ahead and take some notes or replay this if necessary, and tomorrow we're going to go ahead and do some homework on this, alright, as a class. Hope you enjoyed this lesson, girls, and I will see you on Monday.